This video will focus on the steel column command and its settings. You'll learn how to place steel columns and adjust their elevation and insertion point. We'll explore how to work with section libraries and choose predefined or custom profiles. Then, I'll explain two different modeling approaches: manually assigning end releases or using automatic releases through steel connections. We'll also examine design parameters like effective lengths and lateral torsional buckling values, and how to override them when necessary. Finally, you'll learn how to copy steel columns efficiently across your grid layout using the array command. By the end of this video, you'll be ready to model steel columns accurately and flexibly in ideCAD Structural. Let's now continue with the steel column command. I click on the steel column icon. In the toolbar that appears, the first tab is Steel Column by default. Then you'll see other options like two-point column, and one that allows you to define an inclined column by specifying delta values. On the far right, you'll find the settings icon. You'll notice that in all element commands used for modeling, the settings panel is always located on the far right. This interface logic is consistent throughout the software. Let's click on it. In the dialog that opens, the first tab is General. Here, we can see the column name. As I showed you earlier with the axes, automatic naming is applied, but you can always rename it manually. The default name here is CE002. The section is HEB 500, and the material is S235. You can change all of these from the respective input boxes. You can also modify the rotation angle, which allows you to easily place the column at any angle. The elevation input defines the starting elevation level of the column. By default, ideCAD assigns the current plan view to elevation 0, so whichever view you're working in will automatically become the base level. The column height is currently set to 900 centimeters. Since I'll be modeling a 3-story industrial building today, I'll keep this height as is. Under the orientation section, you can define the insertion point of the column, for example, at the center or offset from a corner. It's currently set to middle point. If you need to assign a custom offset, you can switch to user-defined and input specific values as needed. However, I recommend keeping it centered, especially to ensure that you get the correct values when using the effective length method for analysis and design. Next, let's move to the Appearance tab. Here, you can customize the color and perspective view, line type, material texture, and its rendering settings. In the Curvature tab, you can model curved columns. If you want to define a curved column, you can enter horizontal and vertical curve values. But since I won't be modeling curved columns today, I'll skip this tab. One thing to keep in mind: if you plan to model a curved column, this is where you'd enter the radius of the curve. Now I click OK to exit the settings. You'll see the cursor color changes, indicating that the column placement is active. I move close to the axis and click once. The column is placed at the midpoint of the axis. You can always adjust the rotation angle either in the plan view or directly in the perspective view. Now I select another axis. Since I'll be creating an inclined roof along this direction, I want to adjust the top elevation of this new steel column. I double-click the column to open its properties. This time, you'll notice two additional tabs appear. These tabs weren't visible before placing the column. They only become available once the element has been modeled and selected. I'll go over these new tabs shortly. But first, let me change the height of this column to 600 centimeters. I type in 600. Now let's take a quick look at the section field. When I click on it, the section library opens. Here, you'll find the full ArcelorMittal catalog, including standard European and American steel profiles. you can select a predefined section from the library. For example, I'll choose an HEB 400 section. Also note that you can manually enter the name of the section in the field and press enter instead of using the drop-down. Both methods work. I've set the same section for all columns and kept the default. Now let's talk about the two new tabs that appeared. First, it's important to know that ideCAD offers two different modeling approaches. You can model only the structural members, beams, columns, braces, etc., without defining joints, in which case, you must manually assign the end releases, degrees of freedom, for the elements. Alternatively, you can model both members and their connections at the same time. In this case, ideCAD automatically uses the correct boundary conditions defined by the connection type, and you don't need to assign releases manually. Let's explore the first method. If you're not modeling any connections initially, you must define end releases from the Release tab found in the Elements Properties. You select the member, right-click, choose Properties, and go to the Release tab in the dialog. Click the relevant checkbox once. It becomes active and editable. You'll see checkboxes for axial force, shear forces, major and minor, moments, major and minor, for both I-end and J-end. For example, if you want to model a pinned beam without using a connection, you would check the boxes for releasing the shear forces. If you have a special condition, you can also enter spring values to simulate semi-rigid behavior. Now I'll close this dialog. That was the first method. The second method is to place appropriate connections at each end of the element. In this case, ideCAD automatically recognizes the boundary condition based on the joint type. However, it's still important to verify which connection has which release behavior. Let me show you how. I go to the Connection tab. Under the Designed Connections category, all joints listed under single plate are considered pinned connections. The next group contains moment-resisting connections, and so on. After modeling, you can always review the connection releases in the perspective view using right-click Display Analysis Model, which we'll explore more in the second part of the training. Now let's briefly touch on the Design tab in the Properties. We'll cover this in more depth later, but for now, here's what you should know. Under the Design tab, you can edit parameters like the design factor, K and L values for the effective length method, and also LTB, lateral torsional buckling, and CB, C factor, values. When you check any of these boxes, the field next to it becomes editable. You can manually enter a value here if you need to override the automatic values. Why would you use this? Well, by default, ideCAD automatically calculates all these design coefficients. But if you need to override something specific in your project, this menu gives you full control. I click OK to close the dialog. Next, from the Plan view, I drag a selection box from left to right and select all steel columns along the axis. I want to copy these elements along the entire grid. So, after selecting them, I go to the Array command from the vertical toolbar on the left. You'll notice that the software remembers the last use parameters. This is a general behavior for all similar commands in ideCAD. Whatever values you entered last time will be remembered the next time you use that command. So I copy the columns 5 times, spaced at 500 cm intervals. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.